do this.
For number 1, is the following mapping a function?
Yeah.
Yes. To solve number 2, you need to distribute this negative. So you have 8x minus 6x plus 4 equals 10. Then combine your like terms. So 2x plus 4 equals 10. Subtract 4. So 2x equals 6. And divide both sides by 2. Questions on that one? Number 3, someone tell me the domain they got.
1, 0, 2, 3, 5.
In curly brackets, -1, 0, 2, 3, 5. Leaves 2 greatest without repeats. Number 4. Someone tell me how we would solve this for y. Peyton, go ahead.
Subtract, add to both sides. Then, move the y, or positive 2x.
And then what?
And then divide by 3.
So, go ahead.
2/3 x minus 4.
Then we would do the same thing for number 5, but also graph it. Instead of adding, we would now subtract. We have 3y equals negative 2x plus 6. Divide everything by 3. So y equals negative 2/3 x plus 2. Our y-intercept would be at positive 2. Our slope would be at negative 2/3. So go up 2 to the left 3 as many times as possible. And down 2 to the right 3 as many times as possible. Questions on that? I'm going to go through the answers for the SOL A.1. If you have questions or you're sitting down or anything like that, let me know. We can go over any of those. So I'm just going to read off the answers. Number 1 was 7. Number 2 was -7. Number 3 was 576. Number 4 was 33. Number 5 was -19. 6 was -28. 7 was -10. And 8 was 13. Questions on any of those? Make sure you're checking your answers with mine, fixing anything that you may have gotten wrong. Lily, Katie, make sure you're paying attention. Moving on. For number 9, the phrase that verbally translates into this algebraic expression was 5 less than 1/4 times the cube root of x, so D. Questions on that one? For 10 through 15, yours should match mine with the exception of, unless it says a specific variable, you could have had a different variable. For number 10, the quotient of the square root of x and 5 should be the square root of x over 5. The cube root of the product of x and y less 12 would be the cube root of x times y, both underneath the cube root, minus 12. The sum of the square root of 16 and the product of 4 and the cube root of 8 would be the square root of 16 plus 4 times the cube root of 8. This part over here would just me doing extra work. And then number 13, 4 times the cube of a number is 84. That's wrong, because this should be x cubed, not. Because it doesn't say cube root. So 4x to the third equals 84, or you can write it like this. Question on any of those? Number 14. 16 divided by the sum of a number and 4 is 9. So if you chose a different variable here, that's fine. 16 over x plus 4 and then equals 9. For 15, this was like a two-part, like a system question. Amy is 4 years older than Jose, so you need the equation that represents that. Together, their ages add up to 100. So if this is Amy's equation plus Jose's, you would get 100, or you could combine like terms and get this one. Questions on 14 or 15?
Are those J's or
J's. 16 and 17, your words could be different as long as it somewhat represents what this says, then you're good. For 16, you should have something that sounds similar to, could be shorter, simpler, doesn't matter. 5 times the cube root of the product of 4 and x subtracted by the square root of y. So 5 times the cube root of 4 times x minus the square root of y. There are different variations. If you want yours checked, you can raise your hand and say whatever yours is. The sum of y and the cube root of x. You could have also said y plus the cube root of x, or any other variation of that. So I know that was a lot to get done by the end of this week because we had just started it. Now that you have this time, you'll have a little bit more time because the next ones won't be due until the last time I see you next week. So that'll be Thursday. Yeah. So the next ones that will be due by next Thursday will be 2A, 2B, and 2C. 2A you'll be able to do kind of after today, but also after next class. 2B and 2C, there are things that on that we have not talked about yet, so you may or may not know how to do that. That's okay. If you want to try it, that's fine. If you have no idea what to do with those, that's also okay. When we get to those, I'm not going to show you how to do those the right way when we go over them, but show you how you could find them in Desmos. Peyton, what's your question? The negative exponents is the one that's due Friday. Today. Today's Friday.
I keep forgetting today's Friday.
Yes. Yes. Lily, you might be able to see better from 11 than 12, but I'll let you know. Alright, everyone should have notes on their desks that look like this. So last class we talked about negative exponents and zero exponents and those rules. Today we're going to be expanding our set of rules that we know. So when we do this, we're gonna expand these first until we get to whatever the rule might be. So for number 1, if I had x squared and I expanded that, that would be x times x. If I had that times x to the 4th, that would be x times x times x. How many x's do I have altogether? 6. So that would be the equivalent of x to the 6th.
We're really just adding.
Yes. Now, we're going to expand one more time on number 2, but that is going to be the rule, and we'll write that here in a second. And we kind of already touched on this when we were doing radicals, but let's pretend we didn't for a second. For number 2, if I were to expand this, we would have 4 times a times 4 times a times a. So we have the 4s, and we have all of these a's. So this would be 4 squared times a to the 4th. So yes, 16 a to the 4th. So yes, we are adding the exponents, but there's specific rules that go along with that. We can only add the exponents if we have like bases. So I couldn't add the exponents of 4 and a together because they're different bases. So our rule, and you can write this here or at the bottom, doesn't matter. When multiplying like bases together, we add the exponents. If we don't have like bases, so let's say we had a 4 and we had a 6, those aren't the same. We would just multiply those numbers together. We would not do anything with our exponents because they're not the same.
Wait, so it's not about the variable being the same, it's about the number being the same?
Both. Whatever the base is, it has to be the same.
The base is the number.
The base could be the number or the variable. So all of these things are not together. 4 and a are separate. 4 and a is its own separate bases. Each has its own base. Because each has an exponent of 1. So if you were to take that rule now and apply it, that would look something like this. So for this, I see that I have n's, and I have a 4 and a 7. I'm going to bring the numbers out front. And I know that I have all these like bases, so I can add the exponents. So I'm going to write that as 2 plus 3 plus, what's the exponent of this n? 1. So it's going to be 6. So you can do this step by step. You can do it at the same time. It doesn't matter. So we would need to multiply 4 and 7 and add these together to get our new exponent. Do you have any questions so far? Right. For 4, we're going to do the same thing, but now we have C's and D's. We're going to put this in ABC order, so we would have C to the 4 plus 2, and we would have D to the negative 3. We're going to worry about negative exponents last. Yes?
Where do you get the 1 exponent from?
There's an invisible 1 here. It's not there.
Oh, okay.
So our new exponent of C would be 6. Now we have a negative exponent. We have to deal with that. What would this become? Or what would the d to the negative 3 become? 1 over d to the third. And then our last step, we need to combine these in a simplified fraction. What would that fraction be? C to the power of 6 over d to the power of 3. You know that there's nothing else to do because you don't have like bases or more like bases, and none of your exponents are 0 or negative. So there's nothing else to change. Moving on to number 5. You have a bunch of numbers. Move those up front. 5 times 2 times 3. Does not matter the order of the numbers. Do we have multiple x's?
Yeah.
Yes. What are the exponents of those x's?
8 and 1.
Okay, so we have 1 plus 8. Do we have multiple y's? No. So that's just going to say y to the 4th. Do we have multiple z's? Yes. What are the exponents of those? 2 and 1. So we're going to add those two together.
Wait, why are you subtracting 2 and 3?
We're not. We're multiplying. It just look like that. 5 times 2 times 3 is what? 30. Our new exponent for x, 9. Y would not change. And our new exponent for z,
3.
and that would be our final answer. That looks like 11, not 4. I mean, that's yes.
Can you scroll up on number 4?
Make sure you're writing this down. Number 6 is going to be solved similarly. So now we have a 2 and a 2. Since those are the same base, I can say that's the same thing as 2 to the 1 plus 1 times 7. We have 1x and we have 2 y's. So times x squared times y to the 3. This is minus, or it's negative, so we can just put minus 7. You could also put plus negative if you don't want to confuse which one it is. Yes.
Aren't we doing the numbers?
You said y.
Yeah.
Just to make it look easier. This is standard form for exponents, but the number comes first. Yes.
Why are we charging the children the negative sign?
Because these aren't together. You're multiplying these two things. Just like you're multiplying these and these.
Wait, so we 2 times 2 times 1.
Right, that's what we have. But because we have the same base, we took the exponents and added them together. You can do that for numbers or variables. 2 to the 1 plus 1 would give us 2 squared times 7. X squared will not change. Our new exponent for y would be negative 4. 2 squared is 4. If you wanted to now, or you can wait, you could figure out what y to the negative 4th would be. What would that be?
1 over y times
1 over y to the 4th, not times 4. And then multiply. You have 28 x squared times 1 over y to the 4th. Now we need to write this as one simplified fraction. Felix?
y.
Correct. So your question of why didn't we multiply the 2's together, we could have, we would have got the same answer. Because 2 to the 1 plus 1 is the same thing as 2 times 2.
Does it matter if it's 28 is the
that wouldn't make it a simplified fraction if it was on the outside of the fraction. Yes.
Wouldn't x squared just be 1?
Why would it be 1?
I said x squared, wouldn't it just be 1?
And I'm asking, why would it be 1?
If it's x.
We have, this is technically 1x squared, yes. But you're multiplying it to 28. Okay. Just for multiplying like bases and adding their exponents, how do we feel about that? Thumbs up for good, sideways for okay, down for not good. On to the next rule. Now we are raising an exponent to a power. So again, we're going to go back to expanding until we figure out the rule. If you know it already, pull that up. So for x to the third to the fourth, this would be the equivalent of x to the third times x to the third times x to the third times x to the third. And I could expand that even further because I know x to the third is x times x times x. This is why expanding is not the best method. It works, but it gets big really fast. It is 12.
I wish I had lost. Yeah, there's no way I'm doing this. I'm going to write this down right now. Time consuming.
I'm going to start to expand the next one, but we're not going to actually do it all. So if I had a to the negative fourth to the seventh, that would be the equivalent of 1, 2, 3, 4, 5, 6, 7. And each of those is the equivalent of a to the negative 1. I'm not doing that. That makes sense. What would that final answer be? Okay, let's move. A to the negative 28.
1 over 8.
And then it, wow, I put 12. And then we would change it, yes, 1 over a to the 28. Because we can't have negative exponents as our final answer. What we could have also done for this one is, if we know a to the negative fourth is the same thing as 1 over a to the fourth, the seventh, then instead of putting a to the negative fourth, we could replace each of these with 1 over a to the fourth, and so on and so forth, or replace each of these with 1 over a, and so on and so forth, and you would get the same answer. What do we think our rule is? Multiply the exponents. So when we raise an exponent to another exponent, we multiply the exponents together.
I think we also do that for the base. Like
No.
You keep the next one.
We're multiplying the exponents together. The only thing that would change with the base is if it were an actual number, and we'll see that here in a second. Let's move on to number 9. Does anyone still need this? Okay. For number 9, you have like bases and you're raising an exponent to another exponent. When you have things like this, you have to think about your order of operations. Which would come first? Multiplying or raising something to an exponent?
Multiplying. Raising something to an exponent.
Raising something to an exponent. So we would need to worry about this before we deal with that c to the 5th on the outside. So because we are raising an exponent to another exponent, we're going to multiply. So I'm going to write this as c to the 5th times c to the 3 times negative 2. This new exponent on the inside would be negative 6. Again, we're going to leave negative exponents to the end. Now we are multiplying like bases, so what are we doing with the exponents? Adding them. But in this case, subtracting, because it's negative. So we have c to the negative 1, which is
1 over C.
1 over c. Or 1 over c to the first, either or. There is a way to deal with the negative exponent first, but we'll talk about that. We'll come back to this problem after we talk about our next set of rules. Questions on this so far? Number 10. So now we have two things in your parentheses being raised to this exponent. They are both going to be raised to this exponent. Kind of think about this like you're taking this exponent and you're distributing it to the exponents only. So this would be the equivalent of 2 to the 1 times 3, and then x squared times 3. You're taking that exponent and you're multiplying it to every exponent inside the parentheses. There's only one shown exponent. 2 has an exponent of 1, it's just not shown. So this would be 2 to the 3rd, x to the 6th. 2 to the 3rd is what? 8. Forgetting that the things without an exponent has an exponent of 1 will be the thing that throws everything off. So make sure you are not forgetting that. We're going to do the same thing for number 5. If you have things on the inside that you can combine, like maybe you have 2 x's in here, you could combine those first before you deal with the exponents. Use your order of operations. But here we don't. So we're just going to apply the exponent first. So this would be x to the negative 2 times 2, 3 to the 1 times 4, x to the 1 times 4, and y squared times 4. And then we can go about simplifying all of these. X to the negative 4th times 3 to the 4th times x to the 4th times y to the 8th. Now we're going to rearrange. Say that one more time.
Like, so it's kind of like with distributing stuff on the outside of that. Next one behind it.
Yes, you're going this way instead of yes. And so we have like bases that we need to combine, and then you need to move the 3 to the front. So this would be x to the negative 4 plus 4 times y to the 8. What is 3 to the 4th? 1. If you weren't sure, you can put that in your calculator. Use the little caret, top, whatever you want to call that. What would our new exponent of x be? 0. X to the 0 would be what? 1. So So that would completely disappear. And our final answer would just be 81 y to the 8th. Questions on that? Last one for this, same thing. Take this exponent, apply to everything here, and this exponent and apply to everything here. So we would have 2 to the 1 times 5. Once you get the hang of this, you may start simplifying this, like skipping this step and going right to this step, and that's okay. But for now, we're just going to continue doing this. Times a to the 3 times 5. Here we have a negative base being raised to a odd power, so it's going to be negative regardless. But I would get in the habit of putting parentheses around it, so that when you get an even base, you don't get a negative or a positive where you're supposed to get the opposite. And I was supposed to put 1 times 3. A to the 1 times 3, B to the 2 times 3. And then start to multiply. 2 to the 5th, A to the 15th, negative 3 to the 3rd, A to the 3rd, B to the 6th. So we can move our numbers to the front. We have like bases that we can combine. For multiplying like bases, what are we doing with the exponents? Adding them. What is 2 to the 5th? 32. What is negative 3 to the 3rd? Negative 27. New exponent for A. 18. So our last thing we need to do is multiply 32 and negative 27. These numbers do get big. The bigger the exponent is, or whatever. So expect that. What would that number be?
5.
Negative. You're multiplying.
Oh.
Negative. You subtracted instead of multiplied. You should be multiplied.
It's negative.
It is negative.
That's not going to be nice.
Say that again.
It's not going to be nice that we have to worry about having big numbers.
Yeah. How do we feel about raising an exponent to another exponent? Good. Okay. Not good. We have one more set of rules we need to get through. You can probably guess as to what those are, what those rules will be. So we will expand 1, and then if you know the rule, then we can say it. So if I have a to the 6th up here over a squared, I did it. Anytime we're dividing, we're trying to reduce it. So if I have an A up here that has an A down here, I could divide them. That would become 1. Same thing here. It doesn't have to be these 2 A's because you have 6. It could be any of the 2 on top. But you would do that until the A's on the bottom are gone. How many A's would be left? 4. So you are just subtracting. But raising a power to a power is multiplying just the same of this would be true if the bigger or on the bottom, so I'm gonna make up a problem really fast. So if I had, it's supposed to be the opposite.
Is your nose bleeding?
So if I had something that looked like this, I would still do the same thing, but there's nothing else I can cancel. So these would stay in my denominator, and then be 1 over a squared. Yeah. So if you're running through one, I'm going to go ahead and write the rule. When we are dividing like bases together, we are subtracting the exponents. And just like when we were multiplying like bases, if we didn't have like bases, we would just multiply those numbers together. Same thing here. When we are dividing like bases, and let's say we have numbers that aren't like bases, we would just divide those numbers. So you may have fractions within your fractions, or like part of your fraction might be split, and things like that. So for 14, we'll worry about the negative exponents later, and I'll show you another way to do this, how we could deal with the negative exponents first, but we'll do that in a second. We have like bases, C's and D's. We are dividing, so we can subtract C to the negative first minus 5, D to the third minus a negative 4. Be negative what? Not negative 4. Negative 6. And D to the
Negative first.
not negative first, 7. So then C to the negative 6 would become 1 over C to the 6. And we have to make this into one fraction, which would be what? Okay. So the other way we could have looked at this is because we know we have negative exponents, we know that this would get moved to the denominator, this would get moved to the numerator. So we could rewrite this as D to the third, D to the fourth, over C to the fifth, C to the first. Not subtract in this case because we're no longer dividing like bases. Now we're multiplying like bases, so we would add them. So you could do it this way, but in my experience, this gets messier than this. So I would advise, if you're going to do this, to be careful. So before we continue, going back to that other problem. This one, where we had C to the fifth times C to the negative 6. On this, I could have made this negative, or use my negative exponent rule. And then made it one combined fraction. And then I'm dividing my bases, so I'd be subtracting. And then the answer would be the same. So it can be done, just be careful if you're doing it that way. Great. So we're going to do 15 the first way where we're subtracting. If you want to see it done the other way, let me know. I can do that. So for this, we have like bases for x, y, and z. So we're going to subtract them all. X to the 2 minus 1. Y to the negative first minus 4. Z to the fourth minus a negative 3. What would your new exponents be?
Z to the 7.
Of these things, what do we need to change? The y to the negative 5. And what would that be? 1 over y to the 5th. And then simplified fraction, what would this be? X z to the 7th over y to the 5th. Questions on that one? Now we have something a little different. For 16, we have two numbers being divided. We can't simplify them, but they are being raised to an exponent. So we're kind of combining some of our rules now. So with this, we would take this exponent and raise it to both exponents. So 4 to the 1 times 3 over 5 to the 1 times 3. So 4 to the 3rd over 5 to the 3rd. Yes, this would be 64 over 125. You could see if that would simplify. It wouldn't. And here we wouldn't subtract it because we don't have like bases. That would be the answer. In this, as we keep doing this, if we had something we could simplify inside, we would do that first, our order of operations, and then apply the exponent. But if not, we would just go to the exponent. So like for 17, we have different variables, not like bases, so we can't combine anything. So we're just going to go ahead and deal with our exponent. That would be 4 to the 1 times 3, x to the 1 times 3, over y squared times 3. And this would be 4 to the 3rd, x to the 3rd, over y to the 6th. So our last thing, we need to figure out what 4 to the 3rd is. Is 4. In this case, there's nothing else for us to do because we don't have any negative exponents, zero exponents, like bases, anything like that. Okay.
Where'd you get a Z from?
My Z's have lines in them. I mean, not 4 to the 3rd is 64. All right, last one. For 18, on the inside, do we have like bases? Yes, the m's. That means we can deal with these m's before we deal with the exponent. So we are dividing like bases. What would we do with the exponents? Subtract. So that would be 2 to the m to the 3rd, 2m to the 3rd to the negative 4th. Savannah, did you have a question? As soon as we finish this problem. Then we would take this exponent and apply it to everything. So 2 to the 1st times negative 4, m to the 3rd times negative 4. Our new exponents would be 2 to the negative 4th, m to the, what? Negative 12th. Now we need to change these both because they both have negative exponents. 2 to the negative 4th would be what? 1 over 2 to the 4th power. M to the negative 12th would be what? 1 over m to the 12th power. Now we need to figure out what would 2 to the 4th be. 8. No, it would be 16. 2 to the 3rd would be 8. And we need to write this as a condensed fraction. What would that be?
1 over 16 m.
1 over 16 m to the 12th.
Is it okay if you did do the subtracting part? So that's the answer.
Do your order of operations because that could mess you up later. So do what's inside first. Right? How do we feel about dividing like bases? Good, okay, not good. So in all of those examples, except for some of these, we were dealing with one rule at a time. Now you're going to have problems that have maybe 2 things, maybe all 3, maybe some negatives, maybe some zeros, combination of different rules. So on this page, it kind of gives you different steps to help you navigate through those different rules. I'm going to read through those very, very briefly. So step 1 is that if you have exponents or you're raising an exponent to another exponent, deal with that first. Unless you have something on the inside, then deal with that. I would move your like bases together, that way you can see them, but that's not a necessary step. Multiply, when multiplying like bases, add their exponents together. When dividing like bases, subtract their exponents. But if you're multiplying just regular numbers, multiply those together. If you're dividing just different numbers, divide those. They may be fractions, whatever. Instead of what this says, you could do this, but again, be careful. I would say just do your rules and worry about the negative exponent at the end. That way you don't have to worry about flipping it back and forth and things like that. And then simplify coefficients at the end, so anything multiplying, dividing, things like that. So on the next page, there are a lot of problems. I would do as many as you can. Maybe do some here that you're multiplying like bases. Find some where you have some of the same numbers or have negatives or have zeros. Then move on to where you're raising an exponent to another exponent and you have like bases or things like that. And then move on to dividing. Do as many of these as possible. You have time to finish them all, but you don't have to do them all, but do as many as you can. You do have a Delta Math and Khan Academy on this, but they're not due until next week. Khan Academy and Delta Math, because I want to do more of this before they're actually due. So I would say work through these. Let me know if you have any questions on any of these, want me to check anything like that. Do we have questions on what we're doing for the remainder of class? Yes, take it. Yes. So we will be going over this next class, all of them next class. So I would say do as many as you can now.